Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive tutorial on Apache Traffic Server. This isn't your average web server, it's a high-performance proxy and caching engine built for speed and scalability. Originally developed by Yahoo and now maintained by the Apache Software Foundation, Traffic Server is trusted by some of the largest tech companies to power their content delivery networks and API gateways. So why choose Apache Traffic Server over other solutions? For one, it's designed to handle extreme loads with minimal latency. It supports advanced caching mechanisms, on-the-fly compression, and even TLS termination. Plus, its plugin system allows you to tailor its behavior to your specific needs. Traffic Server's architecture is built around three core components. The event system handles asynchronous I/O operations, the cache system stores and retrieves content, and the host database keeps track of origin servers. Together, they form a powerful, scalable foundation. The event system is the heart of Traffic Server. It manages all I/O operations asynchronously, reducing the overhead of threads and maximizing throughput. This design allows it to scale efficiently with modern multi-core CPUs, handling thousands of concurrent connections with ease. The cache system in Traffic Server is incredibly flexible. It supports both RAM and disk-based caching, uses intelligent eviction policies to manage space, and allows you to configure cache hierarchies for distributed setups. Content is segmented for faster access and retrieval. The host database keeps track of origin servers and their status. It enables parent-child proxy configurations, supports failover mechanisms, and helps with intelligent routing decisions. This makes Traffic Server a powerful load balancer in addition to being a cache. Let's walk through the request lifecycle. When a client request hits Traffic Server, it first checks the cache. If there's a hit, the content is served immediately. If not, it fetches from the origin, caches the response, and delivers it. This process ensures optimal performance and minimal latency. Traffic Server supports modern protocols like HTTP/2, enabling features like server push and multiplexing. It also handles TLS termination, offloading encryption from your origin servers and improving overall performance. Traffic Server offers advanced caching features like variable expiration policies, customizable cache keys, and support for cache hierarchies. You can even warm or preload caches to ensure content is ready for peak traffic. To further optimize delivery, Traffic Server supports real-time compression using gzip and Brotli. It can selectively compress content based on MIME type and even optimize bandwidth usage for different client types. Traffic Server's plugin architecture allows you to extend its functionality using C/C++ plugins. You can hook into the request lifecycle to implement custom logic for authentication, routing, logging, and more. There's also a growing community of plugins to choose from. Monitoring is key to optimizing Traffic Server. It provides built-in statistics, configurable log formats, and integrates easily with tools like Prometheus and Grafana for real-time insights into performance and traffic patterns. Security is a top priority. Traffic Server supports TLS termination, rate limiting, and access control via plugins. It also allows secure configuration management to protect sensitive data and prevent unauthorized access. One of the most common use cases is deploying Traffic Server in a CDN. It enables global content delivery with edge caching, dramatically reducing origin load and delivering content with ultra-low latency to users worldwide. Traffic Server also excels as an API gateway. It provides high-performance routing, authentication, rate limiting, and caching for faster API responses. It integrates seamlessly with microservices architectures. For e-commerce platforms, Traffic Server can serve both static and dynamic assets, reduce server load during traffic spikes, and dramatically improve page load times. It's scalable enough to handle Black Friday-level traffic. Traffic Server is configured through a set of text files. Key files include records.config for system settings, remap.config for URL routing, parent.config for cache hierarchies, and plugin.config for loading plugins. The records.config file is where you define system-wide settings. You can tune cache size, memory usage, network ports, and performance parameters. Getting this right is key to maximizing Traffic Server's efficiency. The remap.config file is used to map incoming URLs to origin servers. It supports rejects and wildcards, enables load balancing rules, and allows for flexible routing logic to handle complex traffic patterns. The parent.config file is used to define parent-child proxy relationships, enabling cache clustering. This setup supports failover and load distribution, reducing the load on origin servers and improving reliability. To get the most out of Traffic Server, tune memory and cache size, use SSDs for cache storage, enable HTTP/2 and compression, and monitor and adjust thread pools for optimal performance. Traffic Server provides built-in statistics and integrates with Prometheus for advanced monitoring. You can track latency, throughput, and other key metrics in real time using dashboards. Compared to Nginx, Traffic Server excels in caching and high-throughput scenarios. Nginx is better for static file serving, but both support HTTP/2 and TLS. Traffic Server's deeper plugin API gives it an edge in extensibility. Varnish is another HTTP accelerator, simpler for basic caching. However, Traffic Server is better suited for complex setups with clustering and advanced routing. Varnish lacks built-in clustering support. Traffic Server has an active community under the Apache umbrella. There's extensive documentation, a plugin repository, forums, and even commercial support options for enterprise deployments. Getting started is easy. Install Traffic Server via Package Manager or build from source. Configure with default files, start the service, and test with curl. Monitor logs and metrics to ensure everything is running smoothly. Traffic Server can be easily containerized using Docker. Official images are available, making it simple to deploy in Kubernetes. You can use persistent volumes for cache and scale with orchestration tools. Traffic Server is supported on all major cloud platforms. You can use pre-configured AMIs, set up auto-scaling, and integrate with CDN services for global content delivery. When troubleshooting, check logs in var/log/traffic server, verify configuration syntax, monitor system resources, and use traffic CTL for runtime commands. These steps will help you diagnose and resolve most issues. For advanced users, plugin development uses the Traffic Server API. You can hook into request lifecycle events, compile and load custom plugins, and debug using logging and metrics. Security best practices include using TLS 1.3 and strong ciphers, enabling rate limiting and access control, regularly updating and patching, and securing configuration files to prevent unauthorized access. To monitor with Prometheus, enable the statistics endpoint, scrape metrics, visualize with Grafana dashboards, and set up alerts for anomalies. This gives you deep insights into Traffic Server's performance. For enterprise use, scale using clustering and cache hierarchies, deploy and load balanced setups, monitor resource usage, and plan for failover and redundancy to ensure high availability. The future of Traffic Server looks bright, with ongoing performance improvements, HTTP/3 and quick support in the roadmap, an enhanced plugin ecosystem, and better integration with cloud platforms. Let's recap the key features: high-performance caching and proxy capabilities, advanced HTTP/2 and TLS support, a flexible plugin architecture, and scalability for CDN and enterprise deployments. Traffic Server is ideal for high-traffic websites, CDN, API gateways, e-commerce platforms, and any scenario requiring custom logic or extreme performance. Apache Traffic Server is a powerful tool for caching, routing, and delivering content at scale. It's ideal for high-performance scenarios and extensible through plugins and APIs. Join the community, start experimenting, and see how it can transform your infrastructure. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.